How's it going today, everybody, and welcome back to Shaner's Mechanic Life. So I had a customer come in today complaining about overheating and coolant being pushed out of the overflow jug. So I went out to the parking lot and I took a look. Came here earlier in the day, I let it sit all day, make sure it's good and cool. Took the radiator cap off and put 8 liters of coolant in it. And I'll show you what I found once I go to start it up. Now that vehicle's nowhere near drivable. So what I'm going to do, I'm going to bring it in this shop. I'm going to gradually open it up, test things as I go, systematically, step by step, testing, disassembling, till you get to the point where you have a very good idea on everything that's wrong with the motor. And you haven't spent a dime yet, except for the labor. Now the worst thing you want to do is just jump to a conclusion and say, oh, it needs a head gasket. Order up a head gasket kit, go through all the labor, all the parts, taking it apart, putting them back together, only to have it return on a tow truck, a couple days later with the same issue. It's not going to look very good in the customer's eyes. So we know already that this Isuzu 4HK1 is getting combustion pressure into the cooling system, pushing all the coolant out. So I've already kind of started taking stuff apart, but rather than just rip it apart and look for damage, as I take it apart, I'm going to do some testing and show you how to basically pinpoint where your problem is. So when you do get it apart, you know exactly where you're looking at. So basically I've just got the valve cover and the EGR piping off. I've got all 4 glow plugs out, which goes 1 per cylinder, and that's where I'm going to do some testing. I'm going to do a compression test, and we're also going to pressurize the cylinders and do a leak down test to see where that pressure is going. So I picked up this glow plug compression tester adapter off a Snap-on for these Isuzu engines. Basically you just take your glow plug out and this threads in its place. Part number on that, if you're interested, is EEPV 312D. It's quite easy to use. Just thread it into your glow plug hole, just down to the thread stop. And plug your compression tester in. Just like that. Now before you go cranking it, you want to disable this thing so it doesn't start. So these injectors being electronic, that's why I had the valve cover off. I just undid the harness going to the injectors. So now we know it's not going to start when we crank it. So now you just crank it, watch your gauge till you get a steady reading. This one's reading just over 400 psi. And now we're plugged into cylinder 2, and you just repeat the process for however many cylinders you have. This one's a little bit lower. We are just about 360 psi. So I went ahead and did the back 2 cylinders, and these are our numbers. Cylinders 1, 3, and 4 are all at 400 psi, and cylinder number 2 is lower at 360. Now this is our spec. It should be at 468 psi. So even those 3 cylinders are even, they're still on the low side. So now we're going to do a leak down test, which is we'll pressurize these cylinders, and we're going to find out where that compression is going, and find out hopefully what cylinder or multiple cylinders is causing our compression to get into the cooling system. Now when you do a cylinder leak down test, basically what you want to do is bring it up to the top dead center of the compression stroke, so that way your intake and exhaust valves are closed. That way you can pressurize the cylinder. But since we're already disassembling this, I'm going to do a little bit of an easier way. I'm going to take this whole rocker shaft out. That way all the valves are going to be closed and I won't even have to bar the engine over to pressurize it. And with this particular engine, you don't have to worry about valve timing because the camshaft is separate and it's going to stay bolted in and meshing with the gear train. Okay, so now the rocker shaft's out and all our valves are guaranteed to be shut. A leak down tester basically works off a pressure drop. You put a metered amount of air through this regulator, and this gauge will read the difference in the pressure, giving you about how much percentage leakage is going on in that cylinder. Now to do this, I'm going to use the same adapter going in through where the glow plug screws in. But first, I need to take the Schrader valve out of here. With this adapter being for a compression tester, there's basically a one-way check valve here. So to let pressure go through, but not back. But now we're going to be pushing air the other way. So we need to remove this valve. Which is really quite simple. It's just like something you got in your tire going car. So I've taken that out. Now we'll just put our adapter back together. And just thread it back into the glow plug hole like when we did our compression test. So the leak down tester plugs in exactly like the compression tester. Now ideally you're going to want to pressurize it up to whatever the compression pressure is. But this one is basically more for gasoline engines. It only goes up to 100 psi. Whereas our combustion pressure is 468. So we're doing less than a quarter. But once you get it hooked up, get your shop air to it, you can slowly start raising the pressure. And what you're going to look for is the percentage of leakage. And if it's leaking, you're going to want to listen to where it's coming from. Or if it's going to be coming out the radiator cap, that would be head gasket, liners, cracked head, whatnot. Or if it's coming out the intake, it'd be an intake valve. Coming out the exhaust, it'd be an exhaust valve. And if you hear it coming from like the oil cap or the valve cover area, that means it's escaping past your piston rings. So let's turn up some pressure. And it's slowly pushing the piston down. So we'll turn it up. We're going to bring it right up to 100 psi. And as you're doing this, just keep an eye out. We're actually looking pretty good so far. We got up to 100 psi. And our gauge is saying we've got very low cylinder leakage. But it's pressurizing our cooling system. So far we know that we're getting combustion gas from cylinder 1 into our cooling system. Now we'll repeat the process for cylinders 2, 3, and 4. Okay, let's try cylinder number 2. So just the same as before. Slowly raise up your regulator. And we're already pushing out the cooling system. So we'll just back her off here because we know we got major problems. And now we'll go to cylinder 3. Okay, so we're on cylinder 3. Raising up our pressure. (100 psi). And got about 30% leakage, which we're still in the low range. Now you just put your ear around, see if you can hear where the air is coming from. Now it's hard to tell with the phone, but can you hear it coming up from the crankcase as well as from our intake manifold. So it's basically telling us it's going past the piston rings and intake valve. but not a horrible amount. And finally on to cylinder 4. Just repeat this process the same. And our gauge is going up, but it was staying low there for a little while, and I could hear it coming from either the intake or exhaust. So we might have a little bit of a leaky valve that just seated up, but nothing in the cooling system from there. And it's only 20%. But after having it on for a little while, we are getting pressure into the cooling system through cylinder 4 as well. So back it off, but I could also hear it through the intake and exhaust. Next, what I'm going to do, I'm going to pull all the fuel injectors out, and I'm going to take a look down in the cylinders with my inspection scope. It's a Snap-on BK5600. What I like about this is it's got a side camera. So not only you can look through the end, you can also look through the side. So when you're going down through spark plug holes or fuel injector holes, you just get way better line of sight. So you got the fuel injector harness out. Whenever I undo those, I always do them by hand. Last thing you want to do is break them. And our return line. Next, we'll undo our hold down bolts and pull each injector out one by one. Now with these injectors, they're coded for each cylinder. So you want to make sure you mark them and don't get them mixed up, or else you're going to have drivability issues. Undo all your injector lines, and you can go ahead and pull the injectors out. I always lay them down in the order they came out and in relation with the other parts I've taken out. Take a look at the tips, make sure you don't see anything broken, and also look at the seal here. If you see any black tracing or anything like that, then you know you got a combustion leak coming past there. Now it might be hard to see, but these holes, that's where your injectors go. And inside there is what they call an injector cup. What you want to do is take a look down in there. See if anything looks unusual. Mainly cracks. Because then you can get combustion leaks coming through there, and these have coolant in behind them. So if these are cracked, you could also be getting combustion in cooling system. So take a look at all four. I don't see anything obvious with these. So now we're going to go cylinder by cylinder and put our inspection scope down, see what we see on the inside. Okay, we're in cylinder 1. What you're looking at there is a cylinder wall. You can see quite a nasty score. And as you go up, oh, it's kind of hard to see, but it definitely looks like the head gasket's leaking. You can see that dampness there. What I'll do, I'll take a picture with a scope, and I'll just post the picture, get a clearer version of it. Okay, so cylinder number 1. Right here is your head gasket, and it is wet coming down there in this one spot. The rest of the cylinder is clear. So cylinder number 1, we got a head gasket issue. And cylinder number 2, you can see the top here, that's your valve. Try to focus. Then your cylinder head. Here's your head gasket. And this is part of the cylinder where the piston rings travel. Here is your carbon ridge where the rings don't travel. but you can see there's a crack. What I'm suspecting is that the liner got perforated, so basically you got a hole there and a weak spot, and the crack traveled up. Cylinder number 3 looked good, and here's cylinder number 4. There's the valve, there's the head and the gasket, and we've got coolant leakage again coming down into the cylinder. Now another source is we've got exhaust flow coming through the CGR cooler, and you've got coolant lines. You could have an internal leak here and getting exhaust pressure into the cooling system. So by taking just a little bit of time, doing a controlled tear down and a lot of testing as you go along, we got a pretty good idea on what we're going to into this motor. At the very minimum, we've got a head gasket, cylinder liner cracked, we got some leaking valves on 3 and 4, and also you can hear the leak down test blowing past the rings, so we've got some worn rings, judging by that leak down test as well as their compression test numbers. Next, we're going to pull our intake off, pull the turbo and the exhaust, and pull our cylinder head off. Then we'll send it out to the machine shop to see if the head's warped or any other cracks that we haven't picked up on, and then we can kind of do up a price and give this customer a good idea of what it's going to cost to bring this thing back to life. As you can see, I've got the cylinder head off, and I already see a couple problems. Around these cylinders, they're not one piece with the block. They're called cylinder liners. It's basically a sleeve that drops down into the block. You can see here, there's something called liner protrusion, which these edges of the liners are supposed to stick up above the block just a slight amount. There's an actual measurement you can take. I'm going to look it up in the manual to see how this one measures, but just by feeling, it feels pretty much flush with the block. So that liner protrusion is very important in helping the head gasket seal. You can pretty much see where the combustion gases have crossed over, and these small holes, those go into your water jacket. So that's where our combustion gas has crossed over and gone into the cooling system. As far as the crack in the cylinder liner on cylinder number 2 here that we saw with the inspection camera, now they got it off, I can give you a closer look. A good way of finding a crack, if you don't have fancy tools and stuff, is where you suspected it's cracked, give it a spray of brake cleaner. Now as it dries, keep a flashlight on it, and it'll dry around, and then once this area around it's dry, you're going to see a hairline where it's still wet. You can see right here is where our crack is. See how it's left that line? That's a crack. You can even see it at the top of the liner. So there's a crack there going right into the cooling jacket. And here's a head gasket, cylinder 1, 2, 3, and 4. You can see the back of the engine where the gear train sits. If you look between here, you can see that discolored spot where the combustion gas is crossed over, and this is what seals to the cooling system. Basically, we're seeing that pretty much all the way across the board. If you flip it over, you can even see right here where that head gasket's really breaking down. So what I think is happening here is, like I said before, our liner protrusion's too low and we're just not getting the seal. But we're going to send out the cylinder head, get it pressure tested, and make sure it's not warped, and then yeah, we'll go from there. Well, as you can see, we've got our cylinder head back from the machine shop. Good news is there's no cracks in the head, but bad news is the head is warped. Quite badly, actually. With some cylinder heads where you have timing chains and stuff like that, you can plane the cylinder head flush, provided it's within specs. But unfortunately, with a lot of these engines, everything's driven by intermeshing gears, which means if you shave the head down, that'll change the depth of our gears. So if you plane the head, this gear will be coming down lower, which would force it too tightly into its mating gear, which would just jam the gear train and cause failure in no time. If your cylinder head is warped, you put a new head gasket in, it'll cause it not to sit flushly and evenly against its mating surface, which in a short period of time will cause it to fail, because you might be pressing tight on one side and not so tight in another area. So on top of having a cracked liner, needing new pistons and rings, obviously new head gasket and all the other related gaskets, and now we've discovered that we need a new cylinder head. And if that cylinder head is as badly warped as it is, this deck on the block may also be warped. But I wouldn't be able to get a true measurement of that until we get our liners and pistons out and put a straight edge across and measure it around. So I've talked it over with the customer, gone over some of the numbers, and it's just getting quite expensive to rebuild this, and especially if it turns out for this block to be warped as well. The truck's an older truck. You can order a new long block, but that's basically worth more than a truck is. So what we've decided to do is go with a good, lower mileage, used engine. That just shows you that you have a major problem. Rather than jumping to conclusions and spending thousands of dollars on parts right away, you just take your time, do a lot of testing, and a good controlled teardown. You can have a pretty good idea on exactly what you're getting into before you spend your money or a good customer's money of yours. After all, once you start ordering parts, you're almost committed to fixing that engine. And end of the day, it could just end up costing way more than it's worth. Now he was comfortable with paying the labor to tear this down, so that way he can look at the big picture. After all, it's his money that's going to be getting spent here. So we got our used engine today. Got it from a place I deal with on a regular basis. So when they said it's a good engine, I know I can trust them. Which is very important when you're buying used engines, transmissions, anything like that. You don't want to go through all the labor of putting it in only to have a dud. Now that's better. At least we don't have a geyser of coolant coming out the radiator cap. Well, I hope you found this video helpful, entertaining, and informative. It may seem like a lot of work to tear it down only to find out that, it's not worth doing anything with it. But at the end of the day, you want to make the best decision for yourself or your customer. Well, if you like that video, hit that like button. If you want to see more like it, hit that subscribe button and notification bell in the bottom right hand corner. Just want to end the video by thanking someone who left a comment in a previous video, Leo Lopez. Thanks for the comment. Well, that's it for tonight, everybody. Have a good night, and thanks for watching.